Hi everyone, I'm Dr. Tejashwini. Welcome to my YouTube channel Study with Tej. Today we shall discuss on what data communication is and what are the types of network. So, what is data communication? The exchange of data between two devices via some form of transmission media like via cable is called data communication. The effectiveness of the data communication system depends on four fundamental characteristics. What are they? The very first one is delivery, second is accuracy, third, timeliness, and fourth is jitter. What is delivery? The system must deliver the data to the correct destination. If a sender is sending a data to a particular destination, then is it reaching the proper destination? If it reaches the proper destination, then we say the delivery is successful. Accuracy. The system must deliver the correct data, accurate data. What was sent and what is received so should be same. It shouldn't be tampered or lost. So that is accuracy. Timeliness. The data should be delivered in right time or the time limit or the time frame that has been already described. It shouldn't be an out of time delivery. Then jitter. Jitter refers to the variation in the packet arrival time. So, variation in the packet delivery is jitter, basically the delay. So, these are the four fundamental characteristics of data communication. Moving on, next we would like to know what are the components of data communication. So, there are five components of data communication. If you see here, the sender, the medium, the receiver, and sender is sending the message to the medium, and both sender and the receiver has protocol. So these are the five components of data communication. That is message, that is the information or the data that has to be communicated from one device to another device. That message can be in the form of text, numbers, pictures, audio, or video. Next is sender. It is nothing but the device that sends the data message. The device that will produce some data that has to be communicated. That is sender. Example, computer, telephone handset. Next comes the receiver. It is the device that receives the data message. For an example, computer, workstation, telephone handset, etc. So whatever the data that has been sent, a device that is receiving that is called as receiver. Next is transmission media, the physical path by which the message travels from sender to receiver or source to destination is called transmission media. Example, if it is guided, then twisted pair, coaxial, and fiber optics. If it is unguided transmission media, then it is radio waves, infrared waves, microwaves. Then the last one is protocol. So, protocol is nothing but an agreement that both sender and receiver will get into for any communication to happen. So, it is a set of rules and regulations that has to be followed while sending and receiving the data. So, these are the five components of data communication. Moving further, we have to say the data whatever is sent from the source to destination. So, how what is the form of data? How it can be represented? So, data can be represented in many forms like text, number, images, audio, and video. When it comes to text, text is represented as a bit pattern, a sequence of bits called as codes. And the process of representing the symbols is called coding. One of the coding system called Unicode, which uses 32 bits to represent a symbol or a character. ASCII, that is American Standard Code for Information Interchange, now has 127 characters in Unicode, which is referred to as Basic Latin. Next, coming to Numbers. Numbers are also represented in bit patterns. Numbers are directly converted to a binary number to simplify the mathematical operation. Images. Images are also represented by bit patterns. Basically, images are made up of smallest unit called pixel. If the image is divided into more number of pixels, then the resolution is also more, and hence the image quality is good. To store each pixel, we need a bit pattern. If the image is black and white, then one bit will do the job. For an instance, black is represented by 0 and white is represented by 1. Likewise, if it was a grayscale pic and it has 4 shades, then 2 bits will do the job, like 00 will be black. 0, 1 and 10 are two shades of gray, and 1, 1 is white, would represent these shades. So you got an idea. So depending on how many number of colors you need, depending on that, number of bits will be decided. Several methods are there to store the color images like RGB and YCM. Any pixel with RGB color is made up of combination of primary colors, that is red, green and blue. Likewise, YCM is yellow, can and magenta. So this is with the images. When you vary the value of the color, if it is RGB, red, green and blue, if you vary the value of the color, like red can vary from 0 to 255, likewise green 0 to 255 and blue 0 to 255. Any number you give for these values, that will turn up into a new color, and the pixel is being given in that color. That is how you represent the image in bit patterns. When it comes to audio, unlike text and image, audio is a continuous signal and not a discrete one, just like text or image. It refers to the recording or broadcasting of sound or music. Next is video. Recording or broadcasting of picture or a movie is video. This can be treated either like audio or discrete images moving in continuous, that is converting that into a image by image concept. That way also you can deal with this. So this is all about data representation, how text, number, image, audio and video are being represented in bit patterns, that is easily understandable by the computer. Next, data flow. So the communication between two devices can be of type simplex, half duplex or full duplex. So the flow of data between two devices is data flow. It can be of these three types. Let us learn what simplex is. So simplex mode, the communication is unidirectional. That is, it only moves from one to another one, and uh, it cannot move in the opposite direction. Example: keyboard. It can only give input, but it can't take any other data from computer to keyboard. It is not possible. Keyboard is giving it, it enters the CPU or computer. Then entire capacity of the channel to send the data in one direction. That is how it has been designed. So the entire capacity of the channel is given to send the data in one direction. In half duplex, next is half duplex, each station can both transmit and receive the data, but not at the same time. For an example, walkie talkie. That is, once a person at one end speaks and says over, till then the other person will be listening. Once they say over and they have ended the communication, the other party can talk and say over. Likewise, at a time only one can talk, both cannot speak simultaneously. This is half duplex. Next is full duplex. Both the station can transmit and receive simultaneously. This is bidirectional, just like half duplex, but there simultaneously it was not possible. But whereas here it is possible. So you can send and receive the data simultaneously. In full duplex mode, the signal will share the capacity of that particular link. This sharing can happen in two ways. One is having two physically separate transmission paths or dividing the capacity of the channel between the signals traveling in both the direction. Example, telephone network. So now we learned how uh, data flow shall happen. Next, coming to networks. So after learning what is data, data representation, data flow, and components of data communication, let's know what network is. If we have many devices that can communicate, interconnecting them makes the network. Therefore, the network is the interconnection of a set of devices capable of communication. These devices can be a host or connecting devices. Host can be desktop, laptop, workstation, cell phone, or security system. Connecting devices may be switch, router, modem, etc. Network have to meet some criteria to perform better. What are they? Important one among them are, before that, sorry, let me tell you what is link is. Link is that one which carries the data or the information between two devices, and it is the one which is responsible for sending and receiving the data. It can be either wired or wireless. Wired means guided transmission wherein coaxial cable, twisted pair, all those get into this picture. Then wireless means unguided transmission media where air is a transmission media, infrared, microwaves, and radio waves. These are the examples of wireless or unguided media. As I was saying, network criteria is very important so that to perform better, we have to look into certain metrics. Amongst them, performance, reliability, and security are the main ones. When it comes to performance, it is a measure in transmission time or response time, throughput, and delay. What is response time? Response time is the time elapsed between an inquiry and a response. The factor on which the performance depends on are number of users, type of transmission media, capabilities of the connected hardware, and the efficiency of the software. Performance is often evaluated by two networking metrics, that is throughput and delay as well. Before that, what is transit time? Transit time is the amount of time required for a message to travel from one device to another. Then coming to throughput. Throughput is a measure of how much the data is transferred successfully from the sender to the receiver in the particular time limit. Delay is nothing but the time taken to do the delivery. That is, once any request has been raised, then time taken to give the response. Coming to reliability, it is measured by the frequency of failures, the time taken to link to that recovery from failure. So that is reliability. Security is protecting the data from unauthorized access or from damage and development by implementing policies. So how we do is by implementing some policies and procedures for recovery from breaches and data loss. This is how we give security. So these are three important network criteria which has to be considered for an effective or a metrics to evaluate the network performance. There are types of connections. So in physical structures, we will be learning about type of connections. For communication to occur, two devices must be connected, and the type of connections are point to point and multi-point. Point to point, a dedicated link between two devices. If you can see in this figure, there is a dedicated link between these two devices. Here, that entire capacity of the link is reserved for transmission between two devices. Example, wire or a cable, microwave or satellite links also possible. So this is point to point. Next example is TV and remote for wireless. So here there is only single transmitter and the single receiver. Next is multi-point connection. More than two specific devices share a single link and the capacity of the channel is shared either spatially or temporally. If the several devices can use the link simultaneously, it is spatially shared connection. That is, here there is a single transmitter and the multiple receiver, and the capacity of the link is shared. Spatially, I said it, many will be sharing the resource or the link simultaneously. Temporarily, at that particular time, a particular two devices are using, and time t1, suppose if these two devices, for example, you can see here, if this and this are communicating at t1, then you can have this and this communicating at t2. Likewise, time based you are sharing. So that is time based. If you are sharing the link simultaneously, then it is spatial. So this is with the multi-point connection. Thank you for watching. Hope you have understood. Thank you.